In the early days of coding, we had to hard code rules that would distinguish one class from another. For example, if you've been in machine learning a while, you're probably familiar with the famous iris dataset, which contains information on different types of flowers. In the old days, we would just hard code rules to determine the species of the flower. Say, for example, if the petal size was smaller than 1 centimeter and the sepal length less than 5 centimeters, we can create a rule to classify this as Iris setiza flower. But we've come a long way from there, and now we have machines where we can show a picture of a flower and ask what type of flower this is. In terms of natural language processing, we can build generative models capable of having conversations about flowers, where we could discuss different aspects of the flower and ask the model to identify our flower that way. So, what led to these advancements which now provide us with such powerful models? Large language models are based on a transformer architecture, a type of neural network that was developed by Google Brain researchers in 2017. Transformers are a subset of deep learning. So before we jump into learning about transformers, let's quickly recap what we mean by deep learning. Deep learning is a type of model architecture that can excel at finding patterns in complex data due to its network structure. It begins with input data, such as text or images, and this input is then passed through layers of interconnected neurons, forming a neural network. Each neuron applies a mathematical operation, including adjusting the strength of connections or weights between the neurons. These weights are continually updated during a training phase to minimize the difference between the predicted output and the actual output, a process known as optimization. Through iterative adjustments and learning from vast amounts of data, the neural network gradually fine-tunes its weights to make increasingly accurate predictions or classifications, ultimately producing an output that can include anything from text generation and image recognition to complex decision-making, classification, and problem-solving.